Hey everyone, and welcome. Today, we're jumping right into polynomials. Now, I know they can look a little scary at first, but I promise you, by the end of this, you'll see just how simple and honestly how powerful they really are. Let's get this done. So, let me start by asking you a question. Think about the beautiful arc a cricket ball makes when it's hit for a six. Got it? Okay, now picture a graph showing a company's profits. You know, how it goes up and then maybe comes down over a year. They seem totally unrelated, right? One is sports, the other is business. But what if I told you they're speaking the same secret language? And there it is. That's the secret. Both of these real-world things can be perfectly described and even predicted using polynomials. They are the hidden engine behind so much of what we see every single day. Okay, so here's our game plan. We're going to start with the absolute basics, then we'll uncover something called the secret of the zeros. After that, we'll see how zeros and coefficients are connected, solve some problems together, you'll get some practice time, and we'll wrap it all up with a super fast revision round. Let's do this. All right, first things first. We have to start with a rock-solid foundation. So let's break down what a polynomial actually is. Nice and simple. So here's the official definition. A polynomial is basically just an expression with variables like x or y and numbers. You can add, subtract, and multiply them. But, and this is the most important part, the exponents, the little power numbers, have to be non-negative whole numbers. That's the golden rule. No fractions, no negatives, just 0, 1, 2, 3, and so on. And this slide makes that rule super clear. On the left, everything's good. The powers are whole numbers like 1, 2, and 3. But look at the right side. 4 over x. That's really 4 times x to the power of negative 1. Nope. The square root of x, that's x to the power of 1/2. A fraction, not allowed. And the last one, well, it has a negative 3 right there. So you see, it's all about that exponent rule. Next up, something called the degree. This sounds fancy, but it's incredibly easy. The degree is just the highest exponent you can find in the entire polynomial. That's it. Think of it like its power level. It tells us a ton about what the polynomial looks and acts like. And we give them special names based on that degree. If the highest power is 1, we call it linear. If the degree is 2, it's a quadratic. You're going to see these everywhere. And if the degree is 3, we call it a cubic. These are the big 3 you really need to know for your exams. Okay, we've got the rules down. Now for the fun part. This is where the numbers and letters suddenly create a picture. We're diving into the zeros of a polynomial, which is basically the key to understanding its graph. So what is a zero? Well, it's sometimes called a root, and it's simply the value of x that makes the whole thing equal 0. You're looking for the number that solves the puzzle and makes the final answer 0. And here's where it all clicks visually. The zeros are the exact spots where the graph of the polynomial crosses the horizontal x-axis. See that problem moving on screen? Bam! Right where it touches the x-axis, those points start glowing. Those are your zeros. It's the moment the graph's height is exactly 0. So how many zeros can you have? Well, remember the degree? It gives us a massive clue. The degree tells you the maximum number of zeros possible. A linear polynomial has a degree of 1, so it can cross the x-axis at most once. A quadratic, degree 2, can cross a maximum of 2 times. A cubic, degree 3, can hit it up to 3 times. Simple, right? Okay, we know what zeros are, and we know what coefficients are. Those are just the numbers in front of the variables. Now, let's talk about the secret relationship between them. This, right here, is the key that will unlock almost any problem they throw at you. We're going to focus on quadratics, the standard ax squared plus bx plus c form. And let's say its 2 zeros are alpha and beta. Don't worry about the Greek letters, they're just placeholders, like x and y. The big idea is that there is a direct, magical link between those zeros, alpha and beta, and the coefficients a, b, and c. And here they are, the 2 golden formulas you have to memorize. First, if you add the 2 zeros together, the sum will always be equal to negative b divided by a. Second, if you multiply the 2 zeros, the product will always be c divided by a. Seriously, write these down. They are your best friends in this chapter. All right, enough theory. Math is all about doing. So let's put these golden formulas to the test and walk through some typical exam-style questions together. Okay, question 1. First, let's find the zeros. We can factor x squared plus 7x plus 10 into x plus 5 times x plus 2. That means our zeros are negative 5 and negative 2. Simple enough. Now for the verification. Let's check the sum. -5 plus -2 is -7. Does that match our formula? Negative b over a? Well, b is 7 and a is 1. So -7 over 1 is -7. Perfect match. Now the product. -5 times -2 is +10. The formula says c over a, which is 10 over 1. Another perfect match. See? It works. Now let's go backwards. This time, they give us the sum and product, and we build the polynomial. There's a super handy formula for this. It's always x squared minus the sum times x plus the product. So we just plug in the numbers they gave us. X squared minus 3 times x plus -4. Let's just clean that up a bit, and our answer is x squared minus 3x minus 4. Done. This one might look a little weird because there's no x term, but the process is the same. Set it to 0, so x squared minus 3 equals 0. Move the 3 over, so x squared equals 3. Now to get x, we just take the square root of both sides. But, and you have to remember this, when you take the square root, you need both the positive and the negative answer. So our zeros are the positive square root of 3 and the negative square root of 3. Okay, this one's a bit of a puzzle. The trick here is not to find alpha and beta. Instead, look at what they're asking for. 1 over alpha plus 1 over beta. Let's combine those fractions. We get alpha plus beta on top and alpha times beta on the bottom. Hey, wait a minute. That's just the sum of the zeros divided by the product. We can find those with our golden formulas. The sum, negative b over a, is -5 over 2, which is 5 halves. The product, c over a, is 7 over 2. So we just divide 5 halves by 7 halves, which gives us 5 sevenths. So clever. Here's a classic. 1 0 is the reciprocal of the other. So let's call them alpha and 1 over alpha. Now, when you see reciprocal, your brain should immediately think product, because what happens when you multiply a number by its reciprocal? You always get 1. So the product of our zeros is 1. We also know the product is c over a. Here, c is 5 and a is k plus 1. So 1 must equal 5 over k plus 1. A little bit of easy algebra from there tells us k plus 1 equals 5, so k has to be 4. All right, we've walked through a bunch of problems together. Now it's your turn to take the lead. The only way to get really good at math is by doing it yourself. So let's make you the expert. Here are some great questions to start with. They're very much like the ones we just solved. So go ahead and hit the pause button right now, grab a notebook, and give these a shot. This is where the real learning happens. And for those of you feeling confident and ready for a workout, here's a challenge set. These problems might make you think a little harder, but they use the exact same ideas. If you're aiming for those top marks, this is the kind of stuff you want to master. Pencils down, great job on the practice. Now, to make sure all this information sticks in your brain, we're going to do a super fast lightning round revision. Ready? Let's go. Here it is, the entire chapter in a nutshell. Rule 1, powers must be whole numbers. Rule 2, the degree is the highest power and tells you the max number of zeros. Rule 3, zeros are where the graph hits the x-axis. And finally, for quadratics, remember the 2 golden formulas. Sum is negative b over a, product is c over a. That's the core of it all. Question 1. What's the degree of 5x minus 4x squared plus 3? Don't let the order fool you. The highest power is 2. The degree is 2. Question 2. A cubic polynomial. What's the degree of a cubic? It's 3. So what's the maximum number of zeros it can have? 3! Question 3. For 2x squared plus 8x minus 5, what's the sum of the zeros? Formula is negative b over a. So that's negative 8 divided by 2, which gives us negative 4. Last one. What's the product of the zeros for 3x squared minus 12? The formula is c over a. In this case, c is negative 12 and a is 3. So negative 12 divided by 3 is negative 4. And that's a wrap. You've done an amazing job today. So I'll leave you with one final thought. We started by talking about cricket balls and profit curves. Now that you speak the language of polynomials, start looking for them in the world around you. What other curves, patterns, or paths can you now describe with math? Keep asking those questions. Thanks for watching, and I'll see you next time.